Okay, for today's class, we are going to be talking about inductance resistance circuit. Inductance resistance circuit. In our previous class, we talked about capacitance resistance circuit. They are not the same thing actually. They are quite different from each other. Although the name sounds slightly familiar. Slightly similar, but they are different in entirely different. Okay. So then another name for this inductance resistance circuit is called RL circuit. RL circuit. So quickly, what is an RL circuit? An RL circuit is an electrical circuit that contains number one, resistor. What does a resistor do? It opposes the flow of current. Number two, an inductor. And what does the inductor do? It stores energy in its magnetic field and opposes changes in what? Current. Effects of inductance and resistance. Under resistance, increasing resistance R. Number one, that it decreases current. Number two, it decreases time constant. Then under increasing inductance, number one, slows current growth and decay. Slows current growth and decay. Number two, it increases time constant. Also, what are the two components of RL circuit? And the two components of RL circuit are simple, and I've said it before, is resistor and inductor. Resistor and inductor. Now let's talk about the applications of RL circuit. Number one, they can be applied in radio and television receiver, radio and communication receiver. They can be applied in filter circuit. They can be applied in power supply circuit. They can be applied in electric motors. They can be applied in transformer. They can be applied in electromagnetic relays. Okay, let's quickly talk about the connection of RL circuit in series. Okay, a simple RL circuit consists of a resistor and an inductor connected in series with a DC source. A simple RL circuit consists of a resistor and an inductor connected in series with a DC source. That abbreviation DC means direct current. Direct current. So how does this take place? This takes place now when the switch is closed. When the switch is closed, current does not immediately meet its maximum value. Does not immediately meet its maximum value. Why? Because the inductor there opposes the increase in current. Now, you guys should be familiar with the calculations of connection of a resistor in series and connection of a resistor in parallel. The same thing with capacitor. You should know how to calculate that by now. Okay, for your exercise, number one, state three characteristics of growth of current in a RL circuit when the DC voltage V is applied. As number one, state three characteristics of growth of current in a RL circuit when the DC voltage V is applied. That's number one. Number two, state three characteristics of decay of current in a RL circuit when the supply is removed. Number two, state three characteristics of decay of current in a RL circuit when the supply is removed.
Quiz.